gas law. P1 times V1 over N1 times T1 is equal to P2 times V2 over N2 times T2. All other gas laws relate to the combined gas law by showing that all variables are proportional or inversely proportional to one another.
The ideal gas law. PV is equal to nRT. The ideal gas law puts all variables, pressure, volume, moles, and temperature, together in that equation. This equation is not used to calculate a changed variable, but to find the value of a missing variable. R is not actually a variable, unlike pressure or volume, but a constant called the gas constant. P is pressure, which is a measure of how often particles collide with the sides of the container and is most commonly measured in atmospheres. V is volume and is the amount of space a substance takes up and is most commonly measured in liters. N is moles and is a measure of the number of particles and amount of a select substance. R is the gas constant, which is 0.08206 liter atmospheres per mole and Kelvin. T is temperature, which is the average kinetic energy of the particles and a substance and is most commonly measured in Celsius or Kelvin.
Boyle's law. P1 times V1 is equal to P2 times V2. Boyle's law shows the relationship between pressure and volume. This equation represents an inverse relationship. This means that as one variable increases, the other decreases. In the example shown, when the piston drops and decreases the volume that the gas molecules occupy, the pressure increases.
Gay-Lussac's law. P1 over T1 is equal to P2 over T2. Gay-Lussac's law displays the relationship of a gas's pressure and temperature. They have a proportional relationship to one another, so when one increases, the other does as well. This is shown by our example when the snow front comes through and the box's temperature decreases. The pressure within the box also decreases, as shown by the particles slowing down.
Charles's law. V1 divided by T1 is equal to V2 divided by T2. Charles's law relates temperature to volume. This is a directly proportional relationship, meaning that when one decreases, so does the other. In our example, when we increase the temperature of the balloon with our Bunsen burner, the volume of the balloon also increases.
Avogadro's law. V1 over N1 is equal to V2 over N2. Avogadro's law displays the relationship between moles and volume. These variables have a directly proportional relationship. This is represented by adding air to a bicycle tire. As we pump more particles of air into the tire, we increase the number of moles of air inside, and thus increase the volume of the tire. When the tire pops, the number of moles is decreasing and causes the volume to decrease as well.